Okay, so here's the question. The first four times the sequence is given by this. So the sequence just goes 0, 1, 1, 2. That's just what the sequence is doing so far. And this is the general term. Now, this looks a bit weird. We haven't seen something like this before. Let's look at a basic sequence. Here's a nice basic sequence. I hope we could all say that the nth term of this is 3n, because it goes up 3 each time, minus 1. I think that's the nth term. But what does this actually mean in this kind of notation? Well, it means fn is 3n minus 1. So essentially, f1 is just what happens when you use 1 in here, and you get 2, and that's the first term, right? The first term is 2. f2 is just what happens when you put 2 in here, and that's the second term, right? So all this is if you want the first term, you put a 1 in there. If you want the second, you put a 2 in here, and so on. So there's the function. f1, I put a 1 in here, and they go there. f2, I put a 2 in there, and they go there. f3, I put a 3 in there. But then I notice it actually starts on the 0th term. So I say, well, f of 0, I put a 0 in here. And more than that, they've given me a bunch of stuff. I know f of 0 is 0, so I know that's 0. I know that one is 1, that one is 1 as well, and that one is 2, I think. And I can also simplify a bunch of these, because something's power 0 is 1, so this one here is just a plus b. This one, I don't need to write the ones. That's just a lambda plus b mu. And these two, I can't really simplify as much, but I think I end up with these 4 equations. And now this is good because I have 4 unknowns, a, b, lambda, mu, and I have 4 equations, so it seems like I might be able to solve this. So let's get going with solving this then. The first thing I can say is that I can say, well, from this one, minus a equals b. So I can take all the other equations and I can get rid of b by replacing it with a minus a. So b goes away from minus a, goes away from minus a, goes away from minus a. And now I can look at this and think, well, I can factorize it out in a from all 3 lines, right? So this is a into lambda minus mu, this is a into lambda squared minus mu squared, and so on. Okay, so I'm making good progress here, doing some good work. Got 3 equations on 3 unknowns now, so that's excellent, looking good. Now this one I can't do too much with right now, but look at this one here, that's the difference of 2 squares. Right, so that's going to be a into lambda minus mu, lambda plus mu, which is cool. And now this one, and this is why I stress you have to do the prep before you do this, because the prep talks you through how to factorize this. And factorizing that, I can talk about it a bit if you want to. Lambda minus mu is 0 when lambda equals mu, because if lambda is the same as mu, that's something to the power 3, take away itself to the power 3, which is obviously 0. Now what that means is that lambda minus mu is a factor of this, because lambda minus mu is also 0 when lambda equals mu. It's maybe more clear here, like that's 0 when these 2 things are equal, and this is 0 when those 2 things are equal, so you get 0 equals 0 times something. So that works, right? So this is a factor. Now where have I got this from? Well, I kind of just figured it out by comparing coefficients, but again, if you've done the prep, you'll have seen this before. So I can go into this, and I can replace this difference of 2 cubes with this factorization. Great, and now why is this so good? Well, if I take these 3 equations here, look at this one here. A into lambda minus mu is 1. But a into lambda minus mu appears here as well. So I can say, well, all of this is 1. And it's multiplying by this, so it doesn't do anything, right? Which means this is just equal to that, because all of this is 1, and multiplying by 1 doesn't do anything. So I can say lambda plus mu is 1, which is excellent. I can also do it here, right? All of this is 1 from the top line, which means all of this bit is equal to 2. And actually, that's what they've asked me to show up here. Now, the reason this is great as well is because now I have 2 unknowns on 2 equations, and I know I can definitely do that. All right, so let's just copy this one down here. And now if we rearrange this one, I get lambda as 1 minus mu, and I'm going to put 1 minus mu into there every time I see a lambda. This is good. It's just a single equation in u. I know I can do that. Expand out that, leave that. Collect this up, just pause the video and check my math is good. Now, unfortunately, your heart will sink to learn that this doesn't factorize nicely. So I'm probably, I decided to complete the square, I'm not really sure why. But I halved that number, took away a half squared. That left me with that. That's 5/4 or minus 5/4. Add it to both sides, square root both sides. The root of 4 is 2. Remember to have the plus or minus, and then add a half to both sides. And I think you end up with u as this. So there are actually 2 possible values for u, but we'll get to that in a second. because now I can go back to my equation that links mu and lambda, and I can say, well, lambda is 1 minus this. So let's do 1 minus this. Now this is a bit weird. You probably haven't seen this before. 1 minus a half is nice, that's a half. Now 1 minus plus this is going to be a minus. And 1 minus minus this is going to be a plus. Because remember, I have two different u's that I could have, and I'm kind of doing them both at the same time. But 1 minus the plus version is this minus, and 1 minus the minus version gives me a plus. So either mu is 1 plus this thing, and lambda is 1 minus, or mu is 1 minus this thing, and lambda is 1 plus this thing. Those are my two choices, and that's why this sign is kind of upside down. Except, and they've been really cheeky here, this is difficult to spot. In the question it says A is positive. Now why is that relevant? I'm talking about mu and lambda. Well, look at this line here. If A is positive, this line says a number times another number is equal to 1. Well, if A is positive, that means that this number here must also be positive, because two positives multiply to make a positive. So lambda minus mu must be bigger than 0, which means lambda is bigger than mu, which means lambda is the larger one of the two things. Lambda is the half plus root 5 over 2, and mu is the half minus root 5 over 2, because it must be the smaller one. Okay? Excellent. So that's lambda and mu. Let's go on to finding a and b then. So there they are. Now we can use this equation. 1 equals a into lambda minus mu. Now lambda minus mu is just a half minus a half, which is nothing. And then be careful here, it's root 5 over 2 minus root 5 over 2, which is just root 5. Divide both sides by root 5 to get a is 1 over root 5. And of course, b I can find very easily, it's just the negative version, so b is minus 1 over root 5. And that's all of my things found, and I've done part 1. Excellent. Okay, so that's all my things found. Part 2. Now use this equation here to find f of 6. Okay, so there's the equation. Now it's tempting to just lob these things straight into here like so. Replace the a with that, replace the lambda with this, replace the b with that, replace the mu with that, and then start using f to the f6, which means putting a 6 here and a 6 here. Now, I absolutely do not want to do that because this is messy, right? These things are messy. So what I'm going to do is I'm going to leave these things in terms of lambda and mu, but I am going to keep the root 5s because they're not too bad. They'll be all right. I'll keep those. I don't mind those too much, right? So I'm okay with that. Now, the reason I'm doing this, and the reason these are red, by the way, is because I notice now I can factorize out a 1 over root 5, and I can just have a lambda to the 6 minus mu to the 6. Now, I could have just ran with this. I could have put the 6 in here, and please feel free to pause the video, put the 6 in here, and try to expand this out with a binomial using a 6. Like, it's fine, you can do it, but I'm going to show you a really, I think it's the intended way, but a really nice way to simplify this using algebra before putting any of these surds in there. So let's look at this here. So we've got lambda to the 6 minus mu to the 6. Now, this doesn't look like it immediately, but this is actually a difference of two squares, because I can write this as lambda to the 3 all squared, because you multiply those to make 6, minus mu to the 3 all squared. And now here are my two squares, right? That's this thing squared minus this thing squared. And we know how to factorize the difference of squares. You just put the two things that are squaring, adding each other, and then taking away from each other. So this thing plus this thing comes first, and then this thing minus that thing. So I'm just using the colors to help you track what goes where. But I think I can factorize this into this. Okay, and now this gets even better because now we look at this and we think, well, that's a difference of cubes, but we've already done in this video a difference of cubes. That became that. So I can do the same thing here, right? I can separate it out into lambda minus mu, and then, I mean, this is just the same as this just with lambda and mu instead of a and b, right? So I can do that. And now I go over to here, and again, this is why I'm telling you to do the prep work, because the prep even talks you how to do this. You can also factorize the sum of cubes. The sum of cubes factorizes into something very similar, but with the two signs swapped here. So it factorizes into a plus b into this, and you can check this by expanding if you want to, but it does work. So I can factorize this bit here into those two brackets there. Okay? And now it looks like I'm making everything worse, but think about it. Like, what I didn't want to do was I didn't want to expand a load of surds, like using a binomial, and now I've got all of my powers much lower. So I think it's going to be much easier, but it gets actually much better than that, because this is what I've got so far. And now this is lambda and mu. Now let's think about what these two simple brackets in the middle here, lambda plus u, lambda minus u. Let's think about what those are. Well, lambda minus mu, we've actually already done in this video, so if you remember, well done. But lambda minus mu is a half minus a half, just taking away these two expressions, a half minus a half, which is nothing. And then this minus sorry, I'm doing plus first. Lambda plus u is a half, which is 1. And then these two things cancel, so I'm just left with 1. So this thing here is 1. Lambda minus mu is a half minus a half, which is nothing. And then this minus this, which is root 5. So this bracket is just 1, and this bracket is just root 5. And that's really nice because this root 5 will cancel with this root 5. This 1 doesn't matter, and I'm just left with this. Now I'm going to give you 3 seconds to try and realize why I've highlighted that segment green. Why have I done that? Well, I've made this one green because if you look in the question, we've already shown what this is equal to. We've already shown it's equal to 2. We did that 10 slides ago, and it's still here in the question. So I can just replace that with a 2. And now, having done all that algebra, I'm at a much simpler statement that seems much easier for me to put these two things into than that original thing with the powers of 6s. So knowing those factorizations and being able to do a bit of simplifying has made my life a bit easier here. So let's try and figure out what this thing in the bracket is. Well, it's lambda squared minus lambda times mu plus mu squared. And now I'm going to combine these all into one fraction because I've got the same denominator everywhere. So I can say this is 1, I can just add the numerators because the denominators are the same. So it's 1 plus root 5 over 2. And likewise, I've done that for all of them. Right? And now when I square this, just be a bit careful. You square the numerator and the denominator separately. So the denominator is obviously 2 squared, which is 4. The numerator is 1 plus 5 all squared, which is 1 plus 5 times 1 plus 5. Let's do this. It's 1 plus root 5 plus root 5 plus 5. And I'm going to do that on every one. So this is 1 minus root 5 plus 5, because there'll be 2 negatives at the end. And this one is 1 minus root 5 plus root 5 minus 5. So it's just 1 minus 5. The two, they're conjugates, aren't they? So the two middle ones cancel. Now this here is minus 4. So I haven't done anything to any of this. I've just made this a minus 4. And now I've got 2 negatives here, minus 4 over 4, which means that's a positive. And all I've done is just change that to a positive. Now I've got common denominator across the terms, so I just put the numerator together, this plus this plus this plus this plus, and so on. And now I see that this cancels with that, which is great. 1 plus 5 is 6, plus 4 is 10, plus 1 is 11, plus 5 is 16, and I eventually get that this thing here is 4. And now f of 6 is just 2 times that thing here. So f of 6 is 2 times that, which is 8. So I finally found f of 6 using this thing here. Excellent. Last part of the question then. Evaluate this crazy sum. So the first thing I can do is I can just put f of n in here. Now what I could do again is I could put in what I know a, lambda, b, and mu are, but I'm not going to. I'm going to again try and simplify this as much as possible using algebra. Then at the last possible moment I'll put the things in, and that I think will save me a lot of work. Okay, so what am I going to do? Well, I am going to say that b is minus a. That was one of the things I had earlier. B is minus a. So I'm just going to replace this with a minus a again. I've done that trick before. And now I can see 2 a terms in the top. And by the way, on this bottom, I said 2 to the power n plus 1 is the same as 2 times 2 to the n. Because there's a little 1 there, so you add the powers and you get n plus 1. Now on the top, this factorizes. I can take the a out. And now I've also taken this 2 and kind of left it on its own fraction here. And I hope you can see if I were to multiply that, I would just get 2 times 2 to the n. And on the top I would have 1 times this, which is just this, but I've also factorized this here. Now I'm not going to do really anything here, I'm just going to jump this a over to there. And again, because I'm just multiplying this top when you do fractions, this really doesn't make a difference. I'm just going to jump it over there though. And the reason I'm going to do that is because this term here has nothing to do with the sum. It has no ends in it. This is just a constant. A is 1 over root 5, 2 is a constant, so this is just a constant. And I'm allowed to bring constants out to the front. Okay, and now the last thing I'm going to do is I'm going to split this fraction in 2. I'm going to say this is the same as lambda to the n over 2 to the n minus mu to the n over 2 to the n. And you can see I could put those things together because they have the same denominator. I could put those together to make it look like this, but I want them separated. The reason I want them separated is because when you're adding or subtracting terms in a sum, you're allowed to take the sum individually of those terms. So I'm allowed to do the sum of this first bit, which is here, minus the sum of the second bit, which is there. Now, of course, it's still in brackets because I need to times the whole thing by a over 2. But I can do the sum separately. And now the last thing I'm going to change is this lambda to the n over 2 to the n, I'm going to write as lambda over 2 all to the n. Because when you do something, a fraction to the power, you distribute that power across both. So I'm allowed to do this. And likewise here. And now this is an infinite series, an infinite sum. Now, the formula for the sum of a geometric sequence, if you're going to an infinity and if the ratio is between minus 1 and 1, is this. You just take the ratio and you do 1 over 1 minus that. So if the ratio, if you're going to infinity and if the ratio is between these two things, this is my formula. And now these two things are in perfectly look like this. So this would work beautifully if these things here were between minus 1 and 1. So let's just quickly assess whether they are. Lambda over 2 is this over 2, which is this over 4, right? And that's definitely less than 1 because root 5 is a bit more than 2, so this 1 plus that is a bit more than 3, divided by 4 is less than 1. So that's good. What about mu over 2? Well, mu over 2 is this over 4, I guess. 1 minus something a bit over 2 is minus 1 point something divided by 4. It's definitely between minus 1 and 1, right? So that's also going to be fine. I don't need a calculator to do that. It's definitely going to be okay. So both of these are fine to use this formula with, which is great news because it means do this separately. So this one becomes 1 over 1 minus lambda over 2. And this one becomes 1 over 1 minus mu over 2, just from this formula. The a over 2 stays over here on its own. It's irrelevant right now. Now I'm going to sort out this fraction on the bottom. 1 is the same as 2 over 2. And then when I've got that common denominator, it's 2 minus lambda over 2. So I think I can change that into that. Likewise, this is going to be the same just with the mu. So that's 2 over 2, 2 minus lambda all over 2. I can write that as. And now what do I do when I have a triple fraction like this? Well, you might start seeing more and more triple fractions when you're doing A-level. But one way to think of it is 1 over this fraction is 1 divided by this fraction. Do some KFC, change that sign, flip it over, and of course now we just have 2 over this. And actually the cheap way of doing this is if you have a whole number divided by a fraction, the denominator of that fraction can just always jump to the top. So that just jumps to the top and make a 2, and this stays where it is. Right, so this fraction here is going to become this. That's that bit there. And likewise, the mu is going to be identical just with a mu. Okay, so we're making really good progress. I can factorize out a 2 here because both terms have a 2 in them at the top. So I can factorize out that 2 and leave behind some 1s. That means that cancels with that, and we're doing really well. At this point, what I'm going to do is I'm going to combine those two fractions, I think. So I'm going to, it depends how you like to add fractions, but I think I can think of it as jumping this one over to there and this one over to there whilst multiplying those two together. That's one way I could think about it. So this one jumps to there to make a 2 minus u. This one jumps to there to make a minus 2 minus mu lambda, which is going to end up being positive. And then I multiply the denominators together. Now, what does this numerator come? Well, 2 minus 2 is 0. So it's going to be minus mu minus lambda, which is positive lambda minus mu. And now you can see I've highlighted these things because I think I'm finally ready to put in my numbers and sort out this out once and for all. Right? So there's my thing there. Going to put these things in. Now, we've already worked out lambda minus mu. Lambda minus mu, half minus a half is 0. This minus this is root 5. So this is just root 5. And a is 1 over root 5. So that's convenient because those two things cancel and I'm just left with this. And now I think I'm going to work out what 2 minus lambda is. Now 2 minus lambda is 2 minus all of this. 2 minus a half is 3 over 2. And then minus the root 5 over 2. So that's 2 minus lambda. So that can go in there. I'm actually going to put it as one fraction, I think. That might be might be helpful. And now 2 minus mu is going to be exactly the same because, they've all been pretty identical, except there's going to be a positive there instead of a negative. You can pause the video and check that's correct, but it definitely is. Now, of course, I can just multiply across these fractions. So I get this times this over 2 times 2, which is 4. And now use that trick I taught you a couple of minutes ago. Jump that 4 over to the top. Jump that 4 over to the top to get 4 over this. And I mean, we can all see the home straight coming here. Let's expand these out. 3 times 3 is 9. Plus 3 root 5 minus 3 root 5 cancels. Minus 5. So it's 9, cancelling the middle terms, minus 5. So it's 4 over 9 minus 5, which is 4 over 4, which is 1. And we are done with this question. Really great question. So many great algebraic techniques, from all that factorizing to all of that sort of simplifying of all the terms, putting in the numbers last minute, some good surd work, this good fraction stuff here where we jump the numbers over, loads of good stuff. Really well done if you followed that. It was a great question.